We're getting ready for a shareholders meeting with an energy conversion hot dog cooker demonstration. Energy conversion is important for applications such as battery charging and motor control. Hot dogs let us see and hear the energy. We've made some improvements for the meeting. We have 3 NV systems: power control, a current sensor, and an interlock sensor. Non-NV parts include a rectifier, which converts AC to DC, and a silicon carbide FET to regulate energy to the load. Our power control components are an isolated FET driver and an isolated DC to DC converter for switching power. To test the power control, we programmed a ramp for 20, 40, 60, 80, and 100% power. The meter measures output voltage with a resistor load. We see that the output voltage follows the power setting. The current sensor protects against overcurrent and measures the total energy to the load. In this case, the load is a hot dog. To test the current sensor, we connect the sensor to a constant current power supply. The measured current is pretty close. Linearity drops off at higher currents, but we're only checking overcurrent in that range. We also make linearized smart sensors, but these raw sensors are faster, virtually instantaneous for overcurrent protection. The interlock shuts off power and shows up on the display when the cover is open. Finally, we'll test cooking temperature and uniformity, since people are going to be eating the hot dogs. It's set to finish cooking at 6,500 watt seconds, 6,500 joules. The USDA recommends at least 140 degrees Fahrenheit to kill bacteria. It's 171 Fahrenheit in the center, .177 on the end, so it's safe to eat. Here's a simplified schematic. A detailed schematic, parts list, and controller program are available on our GitHub repository. See the live demo and have a hot dog at our shareholders meeting, August 1, 2024.